Yes.
like I got the feedback that some of the people were not able to understand the post processing segment,
Yes.
right?
Yes. Right.
So for that, I have created like a video illustration.
Hmm.
Simultaneously, this particular session will be more of a like a videoistic kind of a presentation rather than like text or some other format.
Okay.
So like easily everyone will be able to understand what are the insights and how a machining process goes on. I mean, I have created certain videos which will illustrate each and individual process involved into this particular technology.
That's very nice. So.
So I think so. Like after getting the glimpses of this presentation, most of the people will be able to understand what is SLS, how is the process,
Hmm.
what are the like add-ons after printing, what are the advantages, what are the disadvantages, and so on. I mean, they will have a broader mindset comparatively.
Yes, definitely.
Okay,
So
so we'll like start the session by 5 o'clock
by
sharp.
5 o'clock. Okay.
Yeah. Okay.
Rishabh, I think we can start if you are ready.
Yeah. Sure. I'll start.
Sure.
Yes. So, good evening, everyone. So, myself, Rishabh Katiyar. So, I'll be your presenter for today. The sessions, the topics, what we'll cover as of today will be divided into two halves. So, the first and the foremost thing, what we'll understand about is some of the operations for SLA, which we discussed the previous day. And then we'll talk about the fresh technology, that is SLS technology. So, Prahan, I would just want you guys to go through the particular video which I have presented, I mean, prepared for you. And simultaneously, I just want you guys to understand the deep insights why, how, and how, like, I mean, whatever the possibilities are possible with the particular technology, what kind of a operation it has, and what kind of a technology it indulges. So, thereby, just go through this particular video and thereby just let me know if you have any queries.
Introducing the Form 2 high-resolution 3D printer. It starts at the heart of the machine, the optical engine. A high-powered laser is guided by custom galvanometers, creating each layer with exceptional detail. A sliding peel mechanism gently removes the part from the print bed, while a wiper glides across the optical window. A responsive heating system warms the resin to a consistent temperature. This creates a reliable print process, producing beautiful parts without sacrificing speed. It features a 40% larger build volume and a new smart resin system that automatically refills the tank when levels are low.
The Formlabs Finish Kit makes the final stages of 3D printing quick and easy.
Okay. So hereby, like the preliminary process will be the same what we follow in FDM printing, SLA printing, SLS, or any kind of technology. Okay. So the first and the foremost thing what you need to do is you need to conceptualize a particular thing, conceptualize a model, create a particular model. Okay. That means we need a 3D file in order to start with the process. So as soon as you have the 3D file being prepared in any of the CAD softwares, as soon as you have that CAD file along with you, you can import that CAD file, STL file, into the slicing engine of the process or the mechanism. Further, like you might have experienced Cura, so that is a basic, a general purpose slicing engine for FDM technology. Then, like the previous day, we explored preform. So that is the slicing engine for SLA technology. And thus today we'll be exploring one more slicing engine that will be for SLS technology. But prior to get certain things, there is a system, there is a sequence being followed. So step number one, design. If you have the design or you want to design, complete that process and then move to the second process. Step number two is printing. So thereby when you have the design file along with you, you can actually import that design file to the slicing engine of the printer, define the parameters whatever you want, and then further export it to the printer for printing. Step three, like print performance. So within the printer, you are not supposed to do anything. Rest of the operations are being carried out by the printer. So step number four, as soon as the print is done, then what next to like what is supposed to be done. So this particular video will guide you like what are the operations you need to perform after the printing is being done. So like a particular minutes video illustrated you that how is the formation inside a SLA taking place. Now I'll show you after printing what are the operations that needs to be taken care of. Okay.
When your parts have finished printing, the build platform will return to the top of the machine. Always wear disposable gloves when handling uncured resin. Open the cover and unclamp the build platform. Turn the platform over so that no resin drips. Transfer the build platform to the finishing tray. Your parts will be attached to the build platform. Take the scraper and try to get underneath the base of the part. Hold the build platform and tray by placing your other hand below the build platform. Always scrape away from yourself. Scraper is a sharp tool and should be used with care. After removing all of your parts, place them in the rinse tub filled with isopropyl alcohol. We recommend using isopropyl alcohol of 90% concentration or higher. Agitate the part using the rinse basket for a couple of minutes. If the part is very delicate, you may want to skip this step. Let the part soak for 10 minutes. This will remove any remaining uncured resin.
So in this particular video, you saw that after printing, you're supposed to wash the parts in isopropyl alcohol solution. Okay. So like what is the purpose I specifically used isopropyl or the technology involves isopropyl alcohol? Like if anyone can you answer this? Firstly, let me know if I'm audible to you all.
Yes, sir.
Yes, sir.
Okay, great. So in that case, like if any one of you have a bit of understanding about chemicals or why isopropyl is used to like clean the photopolymer, so you can let me know. Okay, in that case, I'll presume like you're not aware of the fact. So I'll just tell you, isopropyl alcohol is one of the best reagents. After TPM, after isopropyl alcohol with concentration 85% or more is the best reagent to be treated with any kind of polymer. So let's say if your hand contains any amount of polymer, if you have dipped your hand into a polymer bin and thus you have liquid or any like form of polymer on your hands, you can simply wash your hands with isopropyl alcohol and thereby everything will be dissolved into it. Simultaneously, an alternative to this solution is a soap solution, but we cannot use that particular solution in order to filter out the particular parts. That's why we use isopropyl alcohol with 85% plus concentration to treat the parts. So let's say we had printed something, our model was printed successfully, but all around the model some amount of gel like material or the resin this photopolymer resin was being present. So what we did, we simply immersed our original model into isopropyl alcohol, just rinsed it and stirred it for some while. Within that particular duration of time, every excess amount of material will be dissolved in isopropyl alcohol, and only the model which was formed that will come out. Rest we'll see here. So you can see that there are certain printed models which the person is keeping in a chamber. So the process after printing goes like, once the print is completed, you need to wash it. After washing, what you need to do is you need to cure the models. So you need to put the particular model in a UV curing chamber. So thereby a frequency of 405 nanometer. So this is the wavelength for the particular light, the UV light, and this frequency hits the model. further cures everything in its desired shape and size. So what this person did over here was, as soon as the washing was done, he just took the parts, kept in a UV oven, kept in a UV chamber, thereby defined the temperature of the chamber. So every photopolymer is prone to get moisturized or polymerized at a particular temperature, simultaneously on the intensity of light as well as the duration of exposure. So within this particular chamber, all the three parameters were being defined, and thereby rest of the operation was carried away by the instrument. So once the UV curing is done, we take out the model from the UV curing chamber, and for the rest of the post processing are done. So hereby, like the person has washed the model, cured the model, and doing the rest of the processes after curing. So over here, the person is using water along with multiple grid uh, sandpapers. So was this clear?
Yes, sir.
Yes, sir.
Okay. So even now, if you experience any kind of a doubt or a query, you are most welcome to ask right now. Anything associated to SLA technology.
Sir, like in the last part of the video,
Mm-hmm.
like in what solution they have dipped it for cleaning?
Okay. So in the I mean the last most part or in the particular mid.
Last
That
most part.
means okay. So the particular solution was water. None other than that. I mean after printing, you're not supposed to, I mean after UV curing, you are not supposed to use any chemical over the particular model. What you can do is you can simply wash away the, I mean these sanded parts with water. That is the only possible thing what you have.
Okay, sir.
So anything else? Should I proceed to SLS?
Yes, sir.
Okay. So introduction to SLS. What exactly is SLS? So SLS stands for selective laser sintering. So it is one of the technologies in additive manufacturing that is from the powder bed fusion family. So likewise, when we talked about SLA, that was from wet polymerization process. Simultaneously, SLS belongs to the powder bed fusion family. So instead of narrating this content, I would like you to go through this video, and that will give you a broader mindset. So this video illustrates that we do have a chamber where UV light is hitting. We do have two separate chambers which has the excess amount of material and that is being thrown to this particular region. So the process is very simple. You do have rollers, you do have a bucket which holds the additional amount of material, and you do have a chamber where the UV curing or the UV this thing laser sintering actually happens. So as per the video, the material is being rolled to the region where the laser is supposed to hit. Then the curing happens, and further again, the roller is responsible for moving the material over the chamber. So further, it creates multiple layers, stacks multiple layers one over another to form a particular composition, right? Second thing, so like why is SLS term very not, I mean not familiar to us? Why is this particular term very new? So the reason is, so unlike FDM and SLA technologies, the patent for SLS technology was released in 2014, and after that too, I mean there were many competitors in the market, but the cost cutting, I mean the cost of the equipments, the cost of the raw material, the cost of setting up the entire workstation, that was on a very high side. So I'll just give you some of the rough figures. So when we say we need to install a FDM solution, so it costs almost around 10,000 euros. So let's say in INR that will be near about to 8.5 lakh. So let's say affordable range is 10 lakhs. So if we need to set up a FDM sort of a solution, industrial solution for FDM, it costs is near about to 10 to 12 lakhs as of now. Then for SLA, if in case we needed to set up a particular station, it costed near about to 20 to 30 lakhs. But in case of SLS, so there was a drastic gap between the two. So the initial range for starting up with industrial SLA was 60-70 lakhs, and further it was very expensive. Thus, many of the people, many of the industrialists, the technology incubators, and the manufacturing units, the research and development team, none of them were able to make use of this particular technology just because of the price range. But as soon as the patent was lifted after 2014, many of the companies came into existence into the market, and further they actually introduced Centerate, a product, and which is capable of producing a very good amount of material, a very good amount of products, as well as the price comparatively is on a very low side. So just go through this video, that this will give you a better insight about the human civilization, how it evolved, and how we are going to experience the additive manufacturing term in today's era.
Humans have always been creators, changers. We're always trying to go further, cross barriers. It has taken us to mountaintops and the seafloor, and even to leaving footsteps on the moon. This is all because we know that we're limited only by our imagination. In the 21st century, we're reaching for even more. The creation of artificial intelligence, bionics, and social media, to name just a few milestones. At Centerate, we go forward. 3D printing completely changed modern thinking about product development. However, the most advanced technology, selective laser sintering, was reserved only for the largest companies. In 2014, Centerate introduced LISA, the first and most affordable desktop 3D printer of all time. It started a completely new era, where SLS was finally available to a full range of industries. Now we are going one step further. Thanks to many talks with our clients and in response to market needs, we proudly introduce Centerate LISA 2. It is larger than the first model, which makes it possible to print more significant parts in one piece. Thanks to a nitrogen chamber, you can experiment with a vast number of materials, which truly makes it a game changer. Plenty of hardware enhancements have resulted in even more reliable printing and software changes, facilitating all processes. Powerful SLS prints at an affordable price, simplicity, and the ability to use multiple materials are all important benefits of Centerate LISA 2. Owning a 3D printer that works in an SLS environment opens the door to vast opportunities. It empowers creation. Thanks to the short and effortless production process, you can spend more time on inspiration and concept planning. With Centrit's end-to-end system, you can make your model functional just after rapid post-production. Having the characteristics of SLS, the prints are excellent for industrial applications. Durable and movable parts with a wide range of materials to use. Its high accuracy and mechanical strength makes it perfect for functional testing and detailed objects. One of our goals is to give you a tool that will enhance your creativity right there in your office or lab. It is up to the designer's imagination as to how to make the most of it. No one should tell you what to do or how to do it. Thanks to Centrit, you can now reach for powerful prints from SLS technology simply on your benchtop. We empower your creation. You do the rest. Centrit. Go forward.
Okay. So in this video, we saw like the evolution thing and what exactly is going on in today's era. So now with the introduction of SLS technology, we are not supposed to worry about the implication of the model and the versatility what a particular model is will be able to offer you. Rather than now we can actually focus on the design, the conceptualization process. Because what exactly happened some years back was you were supposed to pay a lot of attention to the printing process, and thus the further user was not able to pay attention to the designing process. I mean that was uh, that actually led to a negative impact, thereby like many R&Ds, many designs which were not able to be like brought up to the real existence. But due to the implication of SLS technology, now you're most welcome to like open up the ideas, the creativity in your mind, and further you can like simply replicate whatever it is in your mind to the realistic world. The app, like the non-application of supports, the non-application of the printing of multiple models or the stacking of multiple models one over another has made this technology much more faster as well as versatile. So we'll just talk about some things. Why SLS? I mean, why only SLS technology? Why we are talking about this particular technology in so very like exaggerated manner? So the reason is this technology is actually the game changer in the industry. So the very first point what you can actually read is like can someone read the very first point for me, or do you want me to call the names and then ask you guys to like just let me know?
So the first line.
Yes, the first point.
Okay. So a final product composed of many elements printed at once without any additional assembly or post processing.
So thank you for reading this. So from this particular statement, this is like this statement clarifies itself. That means the final product composed of many elements printed at once. So as you can see in this particular picture, that the composition of many individual parts, the composition of many individual parts which are like inculcated together to form a assembly. So a single assembly is being printed as a standalone structure. It's not printed as individual parts and then assembled. So hereby we can actually print the moving assemblies, the conjunctions in a single print without the implication of supports. Because supports are something which actually requires a lot of time to print simultaneously. Then you have to remove those supports, then post process the part, and that actually is additional cost as well as additional time for the user. So thus, due to the implication of SLS, you are most welcome to reduce the supports, simultaneously print assembly in a single go. So the other person can read the second statement for me.
Models with mechanical properties suitable for your application, durable, temperature, and chemical resistant or elastic.
Yes. So as this statement says that models with mechanical properties. So let's say we do have a gear assembly or we do had a spanner. So that was actually supposed to be used in a real world. So you were supposed to like tighten the nut and bolt from that particular spanner. Thus, varying on the application, whatever your application may be, this particular product as well as the OEM Centerate, they do have materials for exact application, whether that application requires some durable material or a temperature resistive material which may be able to like withstand a higher value, let's say 100 degrees at the glass transition temperature, then chemical resistant materials as well as elastic or flexible kind of materials. So the material versatility is on a higher side in case of SLS technology. Then the third point,
Printout printout with high dimensional accuracy even if a model has complicated internal geometry and movable parts.
Printouts with high dimensional accuracy, even if
yes, go on, even if a okay, need not to worry. I'll just say this. So printouts with high dimensional accuracy, even if a model has complicated internal geometry as well and movable parts. So as you can see in this particular photo, that there is a like involvement of spring simultaneously. There are certain joints, there are ball joints, there are butt joints, then there are moving hinges. There are certain clearances between the individual parts. Thus, printouts with high dimensional accuracy. So let's say the clearance between the two mating parts is 0.1 mm. Further, this technology as well as this particular machine is capable of printing your model without overlapping as well as in the desired shape and size. So the minimum layer thickness, what you can actually attain from this technology and from this particular machine is 75 microns, less than that of our hair. And the XY accuracy, the XY average accuracy is 50 microns. That means you won't be experiencing shrinkage or expansion of a particular model more than 50 microns in X and Y directions respectively. Is it clear?
Yes, sir.
Yes. So the last point says
yes,
one
sir.
big yeah. So last point says one big model or several smaller assemblies at once, reducing time and cost of printing one element by printing a lot of them in one go. So I'll not answer this particular question as of now. When we will be opening up the software, when we will be exploring about the software, then this particular statement can be justified. So I'll just once more read it for you. One big model or several smaller assemblies at once, reducing the downtime as well as the cost of printing for a particular model. So we'll just see about this particular point in the software. So hereby we do have the entire workstation for Centerate Lisa. So thereby, I mean, these are the only equipments responsible for the construction of the model, for post processing, for removal, for everything. So this actually is a like neat and tidy setup, which from where you can actually print the models, post process the models, and use the models in their actual applications. So this is the printer. Then hereby you do have powder, I mean cleaning units. Then you do have sandblaster, then you do have vacuum cleaners. So we'll study about all of them in detail. So starting up printing with Centerate Lisa Pro. So this is the equipment, this is the hardware in front of you, and this is one of the prototypes being printed out of it. So yet again, this entire assembly was printed as an individual model. So this rover was a standalone structure which was printed over this machine. So printing with Centerate Lisa Pro. So this particular video will give you the insights of how a SLS 3D printer works and what are the parameters, what are the hardware involvements in a 3D printer. So I just want you guys to like pay a thorough attention to this video, and in case you experience any sort of issues, so after the completion of the video you can let me know. So I'll just start this video.
Pro. In this video, you will learn how to print with Centerate Lisa Pro. Prepare
USB flash drive with S-code file, plastic scraper, powder trowel, ethyl alcohol and a clean cotton cloth, silicone oil. To start printing with Centerate Lisa Pro, you should check if the emergency stop button is released. If not, Turn the button clockwise until it pops up. Turn on the printer using the power switch, and then turn on the ignition key clockwise. Follow the instructions on the screen. Click Start New Print. Press Unlock Lid. The lock remains released for 10 seconds. To lift the lid, press it, and then pull it up. If the temperature inside the printer is over 50 degrees Celsius, it will not open. You can monitor the current temperature on the screen. It is time to upload your printing file. You can do this in 3 ways: by inserting a USB flash card, via Wi-Fi, or by choosing one of the files recently saved on the printer. After inserting the USB flash card, this screen will appear. The USB flash card icon confirms the device has been connected. Click Load from USB and select the file from the list. After selecting the desired model, you will get information about the expected print time and the material you need to use. Information about the printing time is estimated because it depends on the temperature outside the printer. In hot environments, the cooling down can take more time. Important: be sure to use the right material, as the printer adjusts its setting to each kind of it individually. Click Next. Now you will be asked if the printout from your last print was removed. If so, just press the Skip button. If your last printout is still in the printer and you would like to know how to get it out and clean the printer, follow the link to the Cleaning Cinerate Lisa Pro 3D printer video. For this video, we just skip it. In the next step, you should remove and clean the laser protective glass. To do so, remove the split pin from the heating module. Lower the heating module to get access to the laser protective glass. Unscrew both quick release nuts and remove the laser protective glass from the locking holders. Clean the laser protective glass using a clean piece of cloth soaked with ethanol. Remember to wipe the laser protective glass with a dry piece of cloth afterwards. There should be no fingerprints or smudges on the glass. Put the laser protective glass back on its place. Assemble the laser protective glass with both nuts. Close the heating module. Put the split pin back. After the laser protective glass is reinstalled in the printer, press Done. Now you will be asked a few more questions, just to check if the printer is clean and ready to work again. If you have already cleaned the print bed and the feed bed, skip those steps. Now check if the way to the recoder is not obstructed. After clicking Done, both print bed and the feed bed will start to position themselves. In the beginning, they will go down to the bottom and then move up. In our 3D SLS system, you don't have to measure the amount of powder needed for printing. The feed bed will ultimately stop at a position that will show you how much powder is necessary. The print bed will go all the way up. It will stop just a few millimeters from the edge. It is normal. In the next step, fill the feed bed with a printing powder. A message on the screen will remind you which powder should be used. Open the box with your powder and pour it directly into the feed bed. It is crucial to pour in the powder from the low height. Remember to add a bit more powder than fits in the feed bed. Start compacting the powder by gently pressing it with a powder trowel. Don't use too much force, and stop when you feel a slight resistance. Using one of the plastic scrapers, move the powder scattered in the print chamber into the feed bed. Press Done. Now you are ready for the next step. Press Start Leveling button, and the printer will start the process. While leveling takes place, use the scraper to throw the powder remaining on the edges into the chamber. In the end, the whole printing chamber will be filled with the smooth layer of the powder. If you added too much powder, it is okay. It would be poured over to the overflow bin so you can use it later. If you decide that the surface is already leveled, End the process by clicking the Leveling Done button. You can repeat the process by clicking Repeat Leveling. Click Next. In the next step, you should clean 2 Pyrometers window modules. To do it, use a clean piece of cotton cloth soaked with ethyl alcohol. It is best to do it in 2 steps. First with alcohol, and then the dry version without it. Click Done. Now, using the same cloth, clean the recoder's guide bar. Press Done. After that, apply smoothly silicone oil on the whole recoder's guide bar. Don't worry if the oil drops into the powder. It will evaporate. Now the printer is ready to start printing. Close the lid slowly and click Start Printing. The printer starts to heat up. While Lisa Pro is printing, you can check the process via inbuilt camera. To do so, just click the camera button on the printer and you will get a live view of your print. It will last for 10 seconds. During printing, you can also change the printing temperature. Just click the screen where the temperature is displayed and then make it higher or lower using arrows. For regular use, we don't recommend changing the temperature because the printer is calibrated for all our materials. Changing the temperature may affect print quality. When the printing is done, the message Printing Finished and the name of the printing file is displayed. The buttons Main Menu and Remove Printout will appear as well. Click Remove Printout. Now the temperature inside the printing chamber will be displayed on the screen. You need to wait until the temperature falls below 50 degrees Celsius to safely open the lid without damaging the print. You are ready for the next step, getting the printout and cleaning the printer.
Yes. So in this video, we saw about the working of the SLS printer, how and why we are supposed to pour the the powder, where we are supposed to pour the model powder. Then how is the movement of the guide rails defined? What is recoater? Where the excess powder goes? So the excess of the powder goes into this. This is an additional bin. So where the unused powder is stored, and further you can use it in a fresh print. So the whole sole conclusion for this particular process is there is no amount of wastage. So let's say if your model requires 101.45 grams of material to be utilized in printing, that means 101.45 will be the only material utilized in printing. Rest, not even a zero point zero 0.01 gram material is utilized in constructing any other thing. So 0% wastage, 100% efficiency. So do you have any doubt in this particular video, or so far whatever we have discussed, if any one of you experience any sort of doubt, please let me know.
Sir, like in this case, the laser solidifies the powder, right?
Yes.
So, like it will depend on the intensity of laser too. If the build volume is very large, then the intensity will be reduced.
The intensity of the laser?
Yes, sir.
See, intensity of the laser, cause the thing is, only the top surface of the particular polymer, only the top surface of the powder present, so that is getting solidified, and as soon as that layer gets solidified, a fresh layer of powder is being deposited over the model, and further that deposition takes place. So if in case the particular size, heat is already being provided to the chamber. So if in case the size, because the machine also has its dedicated size, let's say 200 cross 200. So the particular model which may be lying in that particular range, that will get solidified and that will be formed the way it is designed. Anything like out of the particular box will not be even formed, because whatever the file we export to the printer, we have to define certain parameters in the software. And very clearly we can see in the software that if the model lies in the particular range, it will be formed. If in case it is out of the range, then there can be certain deviations being observed.
Okay, sir.
So we'll proceed. So we'll have I mean, detailed elaboration sort of a session with the software. So these are some of the insights. These are some of the like advantages. These are some of the insights for the particular software. So these can be mentioned as, so contains the essential features you need to position and reorient the particular model. So these are the generic ones. That means like the files mentioned over here, STL, OBJ, 3MF, 3D. So these are some of the generic extensions which can be imported to any of the technologies. All the files, I mean STL, OBJ, these are the general things which may be either imported to FDM, SLA or SLS. Then quick arrange printable space is available in the software. Zone of the highest print quality, that means in a particular range where you will get the best precision that is displayed there, and so on and so on. So instead of going through these things, I would like you to show the software first. So I have the interface with me. So this is how the interface of the software looks like. So there are certain like series of steps. So we'll start off from the very first step, preset. The first and the foremost thing what you need to do is choose the printer in which you want to print in. So let's say ours was Lisa Pro Revision 8. Then the second thing was to choose the material in which we want to print. So let's say building upon the application, we'll choose PA12, this is nylon, then PA11 onyx, Flexa black, Flexa gray, and so on. So as per our requirement, we'll choose one of the materials. Then we'll choose the layer height. So 75 microns or 200 microns. We do have a range to get, I mean, print our models. So let's say by now we chose 0.15 mm as the apt layer height for our model. Okay. So once we are done with choosing the machine, then the material what we are using, even the version for the material. So let's say ours was V1 only, so we won't change this value. So choosing the machine, choosing the material, choosing the layer height. These are the three things what you will define from here. Next step. Okay. So just remove this model. So second thing is the region. Can you see clearly the green region, yellow and the red region? Can everyone see?
Sir. Yes, sir.
Yeah. So as like one of your colleague was asking that how is the region being like I mean segregated, how we can classify. So yes. So let's say this green region. So whatever the model you will print inside this region. So let's say we are importing any model and it's lying within this range. Anything lying in this range within this green region will be printed 10% with accuracy. That won't experience any kind of issues within the model. Then just beyond this particular green zone is the yellow zone. So if in case your model lies in this yellow zone, your model may or may not experience any sort of distortions or deteriorations. So let's say your model was 1 is to on a 1 is to 1 scale. So like within the process of printing, your model can experience either a shrinkage or an expansion of some amount of percentage. So let's say it was formed around 99.5 percentage and 0.5% was a shrinkage, or any of the critical feature may not tend to form. Then just beyond the yellow region is the red region. So it's not advised to print anything in the red region. Reason is the amount of heat, because there are certain heaters responsible. There are certain heaters incubated into the machinery. So those heaters are able to maintain a regular amount of heat within a specified range. So let's say we are moving away from this particular range. So in this range, the temperature may not be as good as it is in the green range, and simultaneously in the red zone. So the temperature may like vary a lot comparatively to the green zone. So that's why it's advised to print anything which lies in this range. Okay. So we'll check how the range varies. So right now I do have a model with me. So this is the model of a gear. So I have the model, I can actually rotate it in any of the directions. I can actually place it anywhere. So this is totally up to me. Either I want to move it or I just want to drag it or put it anywhere. So the orientation is very simple. It is the same as we use in SLA. That means our flat side, our flat model should not be kept parallel to the surface. Instead, it should be kept at an angle of nearly 40 to 60 degrees from the surface. So right now, the angle, I'm not very sure, but let's say this may be the angle. Okay. And now the model is on the platform. Right now, I do have a particular model and that's lying in the green range. That means it is printable. But if in case our model was somewhere near to the yellow range, then see how the particular formation will be like altering, or will it signify us. So when we'll be zooming over the model, it will show us that one of the edges of our model is lying in the yellow range. Further, these teeth will be formed the way they are designed, but these teeth which are actually in the yellow region, these may actually experience some kind of deviations or dimensional inaccuracies. And further, if in case we move our model from this range to the red zone, so hereby we can see that some error significance. That means the model is almost half of the model is lying in the yellow as well as the red range. And further, if in case we will be printing this model, we actually may attain a failed print from the printer. Thus, it will be a total failure for us. So it's advised to keep your model within the printable range as well as with the specified dimensions. Okay. So let's say this was our model. So let it be. Okay. So we actually had skipped one of the points when we were talking about YSLS. We'll just go through it once. One big model or several smaller assemblies at once, reducing time and cost of printing one element by printing a lot of them in one go. So what does this particular thing means? So let's say in FDM or SLA, if this would have been the surface, can you print anything over this model? So let's say you were supposed to print something just above it. In FDM, can you print anything just above the particular model?
No, sir.
No, no.
In SLA, can you print anything just above the model?
No, sir. It will be a single object only.
Single object. But in case of SLS, you actually can do this thing. So let's say we had one model, we changed the orientation of this one. We had another model. We are keeping a clearance between the two. And now we can actually print these two models in a single go. That means one model can superimpose the other one. One can be over the other one and both of them will be printed without any glitch. So this is possible in case of SLA. That means if something is lying within your X and Y limits, you can actually make use, you can use the 100% Z axis use to print anything. So even if your model may be identical figure or a not identical figure, that may be a moving conjunction, that may be a moving assembly, that may be a bigger volume part. So in case of bigger volume part, you can place it diagonally. So whatever may be the complexity in your model, you're not supposed to worry about the complexities in the design. The only thing, your model will be completed without any performance issues, and you can actually use it in the real life application. So we can do this way as well. We can place them parallelly and print, or we can place one of the just above the other one and print it in a single go. So this is totally up to us. The only thing what we need to consider is that our part should not lie in the outermost zones. It should lie in the green zone, so as to assure that it will be formed without any deformations. Okay. So once we are done with the orientation of the model and placing it in a desired place, now the next thing what we need to do is slice the model. So it's asking us the newest and the firmware version, that is the newest, and it is asking us to create a report. So we'll slice the model. It's actually saving the S code. In FDM and SLA, we actually observe G code. Now it's saying us that the material what we were using was PA12 smooth. The layer height was 0.15 mm. The construction time for the particular model will be 9 hours and 9 minutes. The powder to be filled in the bed, that means in the video you saw that some amount of powder was supposed to be filled in the bed. So that amount is 2.25 liters of powder. Further, so whatever may be the used powder, we need to add 0.39 liters of a fresh powder when we will be printing another model. So every time when we'll be printing any particular model, we need to mix some amount of fresh powder to the existing one so as to make it printable. Okay. So these are some of the additional features. These are some of the additional reports, some additional data being present from this particular model. That means estimated warm up time will be 1 hour and 5 minutes. This is the total time, 9 hours and 9 minutes. Estimated active time is 6 hours 15 minutes. Then estimated cool down time is 1 hour 48 minutes. That means the construction time is only 6 hours and 16 minutes. The rest of the time, near about to 3 hours, is preparation time. Okay. So we'll just check out how the formation is actually taking place. So from the very first layer, so this will be the bed and this much amount of material will be formed. I mean, this much amount of material will be centered. So layer by layer centering happens, one over another, the compilation takes place, and this is how the formation of the entire model will take place. So at the end, we'll get our desired output in the form of the model what we have imported. So once we are done with this, our S code was already saved, and thereby we can actually export our S code to the printer by means of two ways. Either we can connect our printer to Wi-Fi, or we can send our S code to the printer by means of a USB disk. These are the two provisions available. And in the printer section, if in case that might be connected, you could see your printer and you can simply send your parts to the particular printer. So is it understood?
Yes, sir.
So I mean, the software for SLS is very simple. In case of FDM or in case of SLA, we are supposed to worry a lot about the particular supports formation, that whether the internal supports may be formed or the support may not be like subjected to a place where a surface requires some good aesthetics. Then additional construction time, additional construction material. So these all the things are supposed to be neglected in case of SLS. The only thing what you need to consider is the orientation of the particular model. So if in case your orientation of the model is apt enough, the machine will perform to its peak proficiency and thus will give you very good results. So have I made myself clear to all?
Yes, sir.
Okay, good. So we'll resume from where we had left. Okay. So once we are done with this, yes. So once we are done with the software exporting the file to the particular machine, so once our object is printed, then how we need to clean and what are the operations that needs to be taken care of after printing. Okay. So we do have some of the tools responsible for the operations, and you will see like a dedicated video that will guide in a better way. So I'll just start off the video for you. So by the way, this particular image actually shows the accessories what this machine comes along with and what are the useful tools for this particular machine.
The elementary powder tool set contains the basic equipment needed to fill the printer. During the whole process,
or let you clean your printouts from the remaining powder. Simple solutions are often the best. We have tested countless powder in systems, and we are sure that the powder funnel will give you the best results and versatility. It allows to fill the printer without spraying the powder in the air, and is compatible with the new powder container. While the centret funnel was made to keep powder in process clean and easy, there is one more tool which makes it even better. The I.O. box was initially designed to take out ready printouts. Now it has one more function. When you turn it around, it can be used as a guide to powder in the printer. It perfectly fits the feed bed, so it secures the pyrometers and mechanical elements. All of the powder will fall only into the feed bed, and nowhere else. Centeret Trowel isn't a new device, but it was redesigned to fit the whole feed bed. Now the tamping process is faster and is done in just one move. This ensures uniform pressure distribution and proper powder density. Didn't we mention that the simplest solutions are the best? You will love our new foldable tray. It is not only foldable and light, so very easy to store, but has an optimal workspace for initial post-processing. Most SLS 3D printing users don't have dedicated, portable working space for a dirty work, easy to bend and clean. Foldable tray is a perfect solution. You can easily vacuum it, or just simply pour the powder into a bucket. Every device, such as 3D printer, needs maintenance once in a while. The attached service kit with all maintenance parts will keep your printer working for 1,000 hours. Spare recoder cords, silicone foil, set of cleaning wipes, cotton cloths, and spare heater supplies will make you prepared for any typical maintenance action. The ATEX vacuum cleaner is a fundamental tool to keep your workspace clean, but also to recover the unsintered powder for the next prints. Just disconnect the separator from the powder bucket, attach the centeret funnel to the bucket, and fill in the sieve. After a few minutes of sieving, you will have your powder ready for the refreshing process. All these tools come together right now to make your work clean and easy.
Okay. So was the video illustrative? I mean, were you able to get the insights? What are the tools and why are the tools used and how are the tools used in the machine?
Yes, sir.
Okay. Move on. So materials overview. So as per the application, as I had suggested earlier, based on the application, whatever may be your application, whether we want an engineering part to be made or an architectural model or something to be ESG safe. So the manufacturer Centerate has a wide variety of materials available with them. So based on the application, you can use a particular material inside the printer and your outputs will be formed in the same way they are being designed. So let's say we want to do a standard dimensional checking prototyping or a fitment check prototyping, we can use the standard materials. But if in case we require high amount of strength and durability to the particular model, thus we can use the performance materials. If in case we require something to be used with electrical equipments which should be away from the electrostatic discharge, thus we can use special application material. So based on the application, you do have n number of materials available. Furthermore, the specialty about this particular machine is, so let's say like none of the materials offered by Centerate is useful to you and you want to use some other powder material in your printer. Thus, this particular machine can be used as an open source and you can use your own powder inside the machine. Furthermore, these are some of the prototypes which were actually printed from this particular machine, and these are the moving parts which are printed in a individual, which are printed as an individual model without any supports, and this is an integrated model. So whatever the models you will see as of now, those are printed as one. So this is the entire workstation. Whatever the accessories, the machinery which is involved, everything is shown in a single picture. So this is the platform over which the machine is kept. It's quite bulky machine, so that's why it's not directly kept over the platform. Sorry, over the floor and over a platform. So this is the PHS, mainly known as the powder handling station. So thereby you can actually insert all your tools, whatever may be required for the operations, and thus you can keep your containers, the powders inside this particular chamber. Then you do have sandblaster, which actually helps in removing the excess material being deposited all around the part, and in order to do some kind of post processing over the particular model. Then you do have a vacuum cleaner that can be used to suck the excess material as well as to clean the near about places about printing. So now, if you have any questions, do let me know right now, or you can reach out to the following like websites or the email ID for additional info. But I would prefer like if in case you do have anything right now, you can actually ask me.
Sir,
Yes.
can you print complicated mechanisms like guns and all?
Okay, so this is actually a hypothetical statement. I mean, we are not supposed to print guns over these machines. I mean, there may be certain clauses which are responsible. But yes, if in case you'll ask me whether that can be printed or not, yes, it can be printed. But if in case you will try to print, then like I mean, certain legal actions can be taken against you. So it's not advised to like do all these stuffs. But yes, the machine has the potential to do so. Sorry.
Sir, regarding the orientation of the model, earlier you said that it should be kept at the diagonal position, sir. Why? What is the reason?
Okay, I'll just open up the software once again. So okay. So you said that what is the reason why I was keeping the models tilted?
Yes, sir.
Okay. So the reason is, so if in case a model may be flat enough, thus a very big amount of area, a very big amount of surface area will be exposed to the laser, right? Thus it will have to like I mean throw some greater amount of laser over the particular powder and the particular object will be formed. So let's say the model was supposed to be constructed from this point till this point. Okay, so within that particular process, the I mean multiple material depositions were actually happening over the model, and then it was sintering. Then again, a one coat of material came over, then it sintered. So binding actually took place. But if in case we'll put a greater value of surface area towards the platform, thereby we could experience that the bottommost part is warped. That means it may not be flat enough. This particular model can be curved in any of the directions. It can be parabolic, it can be anything. So thus it's advised to keep the model at an angle so as the surface area, the point contact is less and the models will be printed without any issues.
Okay, sir.
Sir, but the heated bed will be enough for like even if the area is like more.
Come again, I didn't got you.
Means like warping takes place when like in absence of heated bed. So if the heated bed is already in the machine, so it shouldn't take place.
See, heated bed. This is this like I mean, heated bed kind of a thing is not available in the machine. Thing is, the particular area where this particular part is getting formed or where it is getting generated. So just above the particular area, you do have heaters. You do have pyrometers as well as you do have heaters, which are actually responsible for providing heat to the topmost layer. The bed which is at the bottom of the powder is not a heated bed, so over the top, you can actually experience some amount of heat. But let's say when the first layer was formed, okay, it went down, then a layer deposited over the model, and then side by side deposition took place. So let's say after 10 to 15 layers, when this particular layer was like somewhat down, so it was submerged in powder. Thus, it won't have like sufficient amount of adhesive properties available in the model or sufficient amount of heat available in the model to make the model remain to its static position or to its idle position. So it can actually experience warping when it is going down. So was I clear, or like I should tell you once again?
Sir, clear, sir.
Okay. So what according to you should be my orientation of placing the model? I'll just change this as well. Is this good or this one? Like let it be number one. Let this be number one and let this be number two. So what should be our orientation to print the model? So
Let's
before
make it
predicting,
one.
yeah, before predicting, just make sure that in this particular orientation, all the hinges are separated. For the overhangs are like at different places, and neither the point contact is on a greater side. So keeping all the parameters, now you let me know. So this is 2, this is 1. Which one?
The inclined one.
The inclined one. And the reason is,
Even though it looks like it has a larger surface area to for the laser to print, but actually each layer will have less surface area to cover by the laser.
yes, exactly. So that's the reason. So that's the only reason why I asked this particular question, and I presume that like you have understood it well. So, like even in this particular case, the particular laser will experience a greater surface area to be exposed to, and the features which are supposed to be kept at an angle are actually kept perpendicular to the surface. Further, the formation could actually deteriorate the features. So, let's say if in case the model was printed successfully, in that case too, when you will be removing the excess powder and the excess material around the model, you could experience that these teeth may not be as per the dimensions. Let's say the angle of this angle was let's say 50 degrees, you might experience some contraction or expansion in this particular hinge. Simultaneously, uh, the region, the cylindrical region may not be as cylindrical what it is available in the software, so you might experience some kind of like arbitrations in the particular thing. So that's why it's always advised to use the particular orientation. In other words, we can say that always a flat model should be kept at an angle of 45 degrees, whether it is SLA or SLS technology. And the reason is same for both, that the point contact area should be less. The least it is possible, the best it will be for your print. So when I say it's inclined, it should neither be like this. If you are inclining it 5 degrees, that also does not make any sense. And if you are inclining it 90 degrees, that is also of no sense. So the angle of inclination should lie between 45 till 60 degrees. That's up to you which one you want. But the suggested one is 45 degrees for both, for SLA as well as for SLS. So any other doubt or query?
Sir, can any magnetic material be printed?
Magnetic material. Okay. So I'll just go through this particular slide, and on the very first page there was something mentioned. So the materials used in SLS are thermoplastic polymers. So that come in granular form. That means that material cannot be metal based. That can be polymer based.
Sir,
Okay.
but there is one where metal is used.
Sorry.
Sintering process. Sir, there is a sintering process in which the metal powder is used.
Yes, exactly. So in that particular case, the intensity or the power of laser is greater. So hereby in SLS, I mean the particular machine which we were talking about, so that was a polymer based particular machine. Whereas when we say a DMLS, so that DMLS stands for direct metal laser sintering. So in that case, you do have CO2 lasers. So hereby we were using infrared laser, infrared diode laser, and in case of metal sintering, you actually use CO2 lasers, which are a very high powered lasers, and those are capable of binding metal particles. I mean, let's say we hereby we were using nylon. So, but in case of DMLS technology, you can use steel, inconel, titanium, whatever the material you want. Is it clear?
Yes, sir.
Any further query? Please don't hesitate. I mean, if in case you do have anything, whether that may be relevant or irrelevant to this particular thing, like you can ask me.
Sir, yesterday you mentioned LCD screens being used in SLA.
Yes.
So why do they use LCD screens while the LED screens are far more accurate and there is no bleeding of light? Why do they use LCD then?
See, basically, VAT polymerization process that actually involves two to three or even more than that subcategories involved into it. So let's say projector based polymerization was one of the techniques. Then laser based is one of the techniques. LED based is also available in the market, as well as LCD based is also available in the market. But the thing is, in case of LCDs, the pixel resolution, so nowadays you can actually see 8K, 4K, so very high resolution pixels are available over the screen. Thus, if in case you will be using LCD screens, it will be able to offer you much more precise objects, much more detailed objects comparatively to the other two.
Okay, sir.
Yeah, I mean, as the technology is growing, people are actually working over the source of light. I mean, our intention, our purpose, or our whole soul concern should be focused towards the projection of light. So that light projection can be through either of the sources. That can be through a projector, that can be through a laser, that can be through like LCDs or the LEDs. So anything. Our whole sole purpose is to project the light. Okay.
Okay, sir.
So I presume that you might be familiar. I mean, you will be able to express whatever the insights I told you about SLS technology to the people whosoever you will meet. So I presume that you might have got some understanding about this particular technology. What are the insights? How and where to use this one? What are the advantages of this particular technology and how the process goes on? So I'll just stop sharing my screen. So, like any one of you have any doubts or any query regarding the SLS or SLA session? No, I guess. So, Mr. Bubhuti, I guess we are done for the day.
Yes, Rishabh. So let's stop here. Hello.
Yes, sir.
Yes. So let's stop here then.
Yeah, we'll surely do so.
Okay. So thank
Okay.
you. Thank you so much. And today is actually the last day of our workshop.
Mm-hmm.
And by this, I thank you as well as your team and also all the participants for attending this workshop. I hope they have learned a lot of things today, and not only today, like throughout the entire workshop. So that is it then. Thank you.
Yeah. Thank you so much. Thank you for your valuable time.
Yes, we'll be in touch.
Definitely. Bye
Okay.
bye.
Bye. Thank you, students. Bye.
Thank you, sir.
Yes, sir.
Thank you, 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 sir.